Welcome back to part 2. That's right. We're going to talk about this, but with better, bigger numbers, okay? You're in 5th grade. You're not going to keep playing with small numbers. All right? So, just like we talked about in the first video, we're going to take our solids and then we're going to try to figure out how would they look as a liquid. And please remember the rule, 1 cm to the itty bitty 3 is equal to 1 ml, milliliter, okay? So 1 cubic centimeter is equal to a milliliter. Now over here I have my beaker, but this beaker only goes to 250, okay? Now, for those of you that don't have an idea, here's my fancy schmancy glass that I like to drink from, okay? And if you look, hey, now I showed you before, that's the 100 milliliter right there, 100, 150, 300. So this cup that I like to drink from goes to 550 milliliters. Now that doesn't look very big, does it? Okay, so 250 milliliters. Well, if you look on my little snazzy cup, that goes right here. Okay, so hopefully I don't spill my drink. 250 milliliters is that much right there. Alright, so when I put my stuff in there, there was 100. So 250, that's not even a big can of pop. Okay, 250 isn't that much. Okay, so what we're saying is these problems, we're going to crunch the numbers. We're going to do our thing. And we're going to see, will it fit in this beaker or will it not fit in this beaker? Now you have to remember, once again, 1 cm is equal to 1 ml, milliliter. And how big can we only go in this beaker that we have here? The highest we can go in this beaker, not my cup, but in this beaker is 250. So we have to do the numbers. So just to do this a little bit better, I'm going to call this A here, B here, C here, D here, and E here. Okay, so we'll figure out what letters will go into my beaker and fit in the beaker and which ones will not. So this is when we look right here. This says, hey, here's 3 numbers, so we're going to have to multiply them together. It doesn't matter because of the commutative property. Commutative. You can move your numbers around as long as they all 3 are multiplying. The commutative property of multiplication, if you're paying attention last year, commutative property of multiplication. So because of the commutative property of multiplication, this is going to be my length, my width, my height. Okay, so I would say 12 times 12 times 6. Well, 12 times 12 is 144 if we remember. Alright, if you want to crunch the numbers, then you can. Alright, so 144 times 6, 144. And like I said, if you want to multiply mom and dad's old way, that's fine. Just make sure you have the correct number. 6 times 4 is 24, carry the 2. 6 times 4 is 24, plus that 2 is 26, carry. That's 864. And remember, that's going to be 864 m to the itty bitty 3. Oh, cm, excuse me. Cm to the itty bitty 3. Well, that fit in our beaker. That's a great big fat no. So I'm going to put a unhappy face. Wah, 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 wah. Okay, so sorry, you don't get to fit in the beaker. You're too big. Okay, so no, not going to happen. But wait, Mr. Nethercott, look over here. Oh, wait. That's got just 2 numbers. But if you look closer, abracadabra, if you look closer, that is cm to the itty bitty 2. That means there's actually, that 20 is made up of 2 of the cm's. So, are there really 3 numbers? Yes, there are. And what do we do with these numbers? We have to multiply them. So, I'm going to multiply my 20 times my 12 hey, if I remove that 0, that's 2 times 12. 2 times 12 is 24. Just add my 0, and that's going to be 240 cm to the itty bitty 3. Will that fit in my beaker? Yes, it will. All right, so you're going to get a great big smiley face, and I'm going to put the letter B over here. B will fit in my beaker. All right, now let's take a look at letter C over here. Okay, so once again, we know this is going to be length, width, height, and because of the commutative property of multiplication, we can multiply and move those numbers around if we want to because of the commutative property of multiplication. So I'm going to write this down right here. So I've got 25 times 5 times 2. Oh, snap. Well, 2 times 5 is 10. So I'm going to write 25 times 10, and 10 times anything. Hey, if I move that 0 out of the way, that's a 1. So that's going to be 25 plus a 0. That's 250 cm to the itty bitty 3. Will that fit in my beaker? Yeah, that's going to fit in my beaker. So B is going to go in there, and C is also going to fit in my beaker because it just taps it out at 250. So I'm going to give you a great big smiley face. Yay! All right, so we got one unhappy face. Boo! We got 2 smiley faces. Yay! Okay, so A, B, C, D. Now we're going to D. Oh, hey, so we're going to write down 5 times 3 times 15. Oh, snap. Well, then we're going to say 3 times 5 is 15. 15 times 15. Uh-oh, I didn't memorize that one, so this one we're going to have to do some work. Okay, so we can do Mom and Dad's way. 15 times 15. 5 times 5 is 25. Carry the 2. 5 plus 2 is 7. Don't forget the 0 placeholder, dead guy. Okay, so I'm going to put the 0 there with the X's. Oh, he's dead. Alright, and then 1 times anything is that anything. So there's my 15. Draw my line. That's a 5, 12, 225. 225 cm to the itty bitty 3. Will that work? Will that fit in my beaker? Yes, it will. 225 will fit in my beaker. So I'm going to put the letter D over here. D will fit in my beaker of 250, and I'll give this one a smiley face. Yay! All right, so we've done A, we've done B, we've done C. Oh, our last one, but wait, there's only 2 numbers. Once again, once we zoom in, dun, 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 dun. Hey, there's a CM to the itty bitty 2, so that means, hey, since it's an itty bitty 2, that's 2 numbers put into 1. So we'll come back out of there, and we'll say, all right, cool, what do we got? All right, well, what we got is 75 times 3. So I'll say 75 times 3. Oh, you can't do any work that way. You have to do it underneath. Well, you can if you're really super gifted. I'm not. Okay, 5 times 3 is 15. Carry the 1. 3 times 7 is 21. Plus 1 more is 22. 225 cm to the itty bitty 3. Will that fit in my beaker? All right. Looks like it will. 225. So let's check our numbers using lattice. Okay. So I'll put my happy face here for now. Yay! Yeah, happy face. All right. So let's check our work and see if we have a goof. Let's check our work. So, like I said, I like to use lattice to see what's going on. Alright, so on this one, our numbers were 1, 44, and 6. So if I do this, okay, I'll go 1, 4, 4, draw my box. 1 gets a lane, 4 gets a lane, and my 6 is here. Corner, corner down, corner down, corner down. That's 24. That's 24. That's a 0, 6. Oh, hey, what is it? It's friend time. Okay, does he have any friends? No, he's in the corner. He's lonely. That's a 4. He has some friends. 2 plus 4 is 6, and 2 plus 6 is 8. So 864 cm to the itty bitty 3. As you can see, once again, there's Mom and Dad's old way, and here is the new fresh hotness. And if you look, the reason why I like this is because if you make a mistake, we can see it right there in your face. Pow! Okay, 6 times 4, 24. Doesn't that look like 24? Yes. 6 times 4, 24 again. Alright, and 6 times 1 is 0, 6. Why? Because there's nothing in the tens place. And then we just add. Here, if you make a mistake, can you see where your mistake is at? No. Alright, now we're going to look at 12 times 20. So I'm going to erase this smiley face, and I'm going to put 12 on top, draw a box, and then I'm going to draw 20, draw a box. Now, what do you notice? There it is. Corner down, corner down, corner down. That's going to be a 0, 4. That's going to be a 0, 2. That's going to be, and 0 times anything is 0. So these are all zeros. Bye-bye. Oh gosh, now it's friend time. Okay, so that's 0, that's a 4, and that's a 2. So, 240 cm to the itty bitty 3. Alright? And that's showing the work. Moving on. Alright, so let's look at our 15 times 15. I'll erase my happy face, and I'll go 1, 5, box, 1, 5, box. Corner down, corner down, corner down. Ooh, that's kind of ugly. Let's try that again. Alright, 15, draw a box, 1 has a lane, 5 has a lane. Okay, I'll move this over where you can see what I'm talking about. Alright, 1 has a lane, 5 has a lane. Alright, and then I'll draw my line here. 1 has a lane, 5 has a lane. Corner down. Corner down. Corner down. There is the boxes like we do. 1 times anything is at anything. So this is going to be a 5 right here. That's going to be a 1 right there. 0 here, 0 here. Why? Because there's nothing in the tens place. 5 times 5 is 25. 5 times 1 is 5. So we'll put that in as a 0, 5. Now we'll go friend time. Here's a 5. 5 plus 5 is 10. Plus 2 is 12. I'll put down the 2. Carry my 1. 2, 2, 5. 2, 2, 5. So, once again, if you make a mistake here, can you see it? Yes. Yes, you can. Make a mistake here, can you really see it? I can't. Alright. So once again, what you're looking at trying to do is say, hey, where would I be on my beaker? Alright, and then what's that one? So you get the idea of what to do. Now, if we want to do this individually to the beaker, alright, I'll erase this. Alright, I'm in a good mood. I want everybody to see what I'm doing. Okay, so if I look at that, and here's my beaker. My beaker has all my numbers like I want to 250. So the first one, what was my number? 864. Will that fit in there? No, it won't. If you've ever heard the phrase, then the cup runneth over, that would be a good example of it. Alright, B. B says 240, so you look here, here's 200, here's 250. So if you were going to do it, we call that like 210, 220, 230, 240, 250. So if we're trying to do the 240, we would shade everything here. Right? Because you'd look and say, okay, if that's 200, 210, 220, 230, 240, 250. Oh, hey, we're going to 240. So that's why we went drew that mark, shaded in. Okay, so that was for B. All right, C. C's number was 250. So if it was 250 on C, because 5 times 2 is 10, 10 times 25 would be 250, we would have ended up shading what? Everything. It'd be up to the very tippy top. Okay? Up to the very tippy top. Woo, that's a lot. Okay? Woo, to the tippy top. You wouldn't want to spill that. Alright, so A, B, C, D. D's at 225. Oh boy, now it gets challenging. So, if we're going to 225, alright, we'll erase this top part here. Alright, so if we're looking for 225, once again, I said, hey, let's go 210, 220, 230, 240, 250. So 225 would have to be between 230 and 225 would have to be between the 20 and the 30 and our halfway mark. So tick 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 tick, and shade it all in. Yay! All right. So we'd have to find between that 20 and that 30 mark, because 225 would be in between 220 and 230. Alright, so that's D, A, B, C, D, E. E is 220. Wow, what? E is 225? Okay, let's check that work. So, if I put it in the box, 75, put a box, 7 gets a lane, 5 gets a lane, put a 3 right here, corner, corner down, corner, corner down. 3 times 5 is 15, put that there. 3 times 7 is 21. Hey, see, if I make a mistake, I can see where my mistake is coming from. Okay, what time is it? Friend time. That's a 5, that's a 2, and that's a 2. Huh. So, can you get 225 a different way? Yes, you can. Alright, so, 225, and there it is again. I hope you see the concept of what we're talking about. We were saying, hey, we want you to be able to find what I look like as a solid. Okay, if I take my solid and I change it over to a liquid, where would I be? Alright, there it is, the 100 that way. Alright, that's what we did. Solid to a liquid. Just like that. There's bigger numbers. Alright, catch you later.